So today we're going to take a look at solving systems of three variables by using the substitution method. If you look over to the left, here are the steps. Step 1 says choose one equation to solve for one of its variables. Step 2, substitute the expression that you solved into the other two equations. Step 3, write the two new equations as a system, then solve. And then step 4, substitute the two values you found back into one of the original equations and solve. So again, just like we did with elimination, I'm going to label these equation 1, equation 2, equation 3. Our goal is to find our equation 4 and 5. And we want equation 4 and 5 to be a system of two equations with two variables. But today we're going to use substitution. So what you need to do is you got to choose 1, 2, or 3 to solve for either x, y, or z. Well, if you look at number 3, it's already solved for x. So we're going to use that. So we're going to box this up. And then we're going to ship it out to the other two equations. When I ship it out to the other two equations, after I clean them up and simplify them, those become my equation 4 and 5. So equation 2 would be negative 3z plus 5y plus z equals 4. I'm substituting negative 3z in place of the x in equation 2. So now we're going to add our like terms here. Negative 3z plus z would be negative 2z plus 5y is equal to 4. So this is going to be our equation 4 now. So we'll call this our equation 4. So to find our equation 5, we take the negative 3z and we plug it in for x into equation 1. So we're going to have 3 times negative 3z plus y minus 2z equals 22. Multiply these together, we get negative 9z plus y minus 2z equals 22. Combine like terms. Negative 9z and negative 2z makes negative 11z plus y equals 22. So this is our equation 5. We're going to call this our equation 5. So now it's like a brand new problem here. We need to solve this system of equations using equation 4 and 5. You don't have to use substitution anymore. You can. We just use substitution to get to equation 4 and 5 in this process. Once you get to equation 4 and 5, you can either use elimination or substitution, whatever you prefer. So let's take a look and see what might be the easiest way to solve this. Well, let's just do elimination. Let's multiply the bottom equation by 5. So we get negative 55z plus 5y equals 22 times 5, 110. Let's keep equation 4 the same. I'm just going to rewrite it so everything's lined up nice and neat. But they're not going to cancel out. What I should have did, I didn't notice, I should have multiplied by negative 5. So let me just change this to a negative 5. So that would change the signs of everything in this blue equation. And then my y's will cancel each other out. So this would be positive 55z minus 5y equals 22 times negative 5, which is negative 110. Now we can add these together. So we got 55 minus 2 is 53z. These cancel out. 100, negative 110 plus 4 is negative 106. Divide both sides by 53. We get z is equal to negative 2. So now we need to find what y is. So we can substitute negative 2 in place of the y into equation 5. So we got negative 11. Substitute it in place of the z, right? Z is negative 2. So we got negative 11 times negative 2 plus y equals 22. This would be 22 plus y equals 22. So minus 22, minus 22, y is equal to 0. So now we're on step 4. Step 4 says plug your two answers you got back into one of the original ones. Doesn't matter which one you use to find the third variable here. So let me scroll up here so we can see the original 3 equations. We got z is negative 2, y is 0. Well, let's just use the third equation. The third equation says x is equal to negative 3 times z. And we found z to be negative 2. So x would be 6. So the solution to this system is the point 6, 0, negative 2. So that's the substitution method for solving a system of 3 equations.